Hello. You may have heard of a peculiar programming language called Lisp. Or maybe you have never heard of Lisp and you're curious about what Lisp is, why it was created, and what you can even do with it. This video will cover a very basic description of Lisp and showcase some basic applications of the language. What is Lisp? In terms of Lisp's syntax and the way it handles things internally, Lisp's approach to programming is very different from other widely used programming languages like C++ or Python. Lisp is a programming language where everything in the language is either an atom or list. A list is enclosed in parentheses and may contain atoms or lists within it. Atoms are anything that is not a non-empty list. They are symbolic in nature in that they represent something, or in other words, hold a certain value. Some atoms have names that match their value, such as numbers, single characters like the addition operator, or a string of characters enclosed in quotes. Atoms may represent other atoms or lists and act as a descriptor to a value. For instance, an atom named val may represent the number 2. Expressions or symbolic expressions are a combination of atoms and lists. If you're wondering how this all works in the background, it is handled by Lisp's internal data structure called a linked list, hence why Lisp stands for list processing. Lisp's development dates way back to 1958 with John McCarthy, a very influential figure in artificial intelligence research. In fact, McCarthy's inspiration for Lisp dates even further to 1956 during the first organized study of AI known as the Dartmouth Summer Research Project on Artificial Intelligence. During his time here, McCarthy began to consider early design elements for his own list processing language. It was after hearing the description of IPL2, which was a list processing language used in the implementation of the logic theorist program written by Alan Newell, Herbert A. Simon, and Cliff Schur, that led McCarthy to imagine a language like IPL2, but with an algebraic approach. Jumping to fall of 1958, the Artificial Intelligence Project at MIT led by John McCarthy, Marvin Minsky, and their team would begin implementation of Lisp that would include expressions, recursive function definition, garbage collection, and an interpreter. This Lisp environment would be called Lisp 1. McCarthy and his team would further develop on Lisp 1 to correct glaring deficiencies in the language. This would lead to Lisp 1.5. A Lisp 2 was also planned for development to fix any further limitations of the language, but was dropped due to costs and collaboration issues. Moving forward to today, the language lives on in many dialect variations such as Common Lisp, which is what will be used in this video. Here are a few basic applications of Lisp. We can evaluate simple arithmetic by creating an expression utilizing a mathematical operator in the beginning of a list, such as the addition operator, and a series of numerical atoms following. This notation is called prefix notation. We can run the expression directly to evaluate it. Here is an example using nested lists. It can be noted that the nested lists in this expression are evaluated first. Here is an example of creating functions using the defun macro in Lisp. Defun defines an atom function, square, that takes in a list of operands, in this case it's only x, and computes it as defined by the list of atoms, *xx. We can call this function in the same way we evaluated simple arithmetic. Here is an example demonstrating recursion in Lisp. The atom function, factorial, takes an operand n and returns the factorial of n. The logic in our factorial function contains an expression with 4 atoms represented as an if, a conditional statement, a base case, and our recursive call. These are a few basic examples of Lisp. I'd recommend, if you are interested in trying Lisp out for yourself, that you download Common Lisp on your own computer, or finding a free online Lisp interpreter to use. Thank you.